Okay, so now we'll go through example 4 on page 29. It tells us that we're mixing together 1.68 moles of PCl5 with 0.36 moles of PCl3. Now, if you look at the equation down here, what we're mixing together is the reactant with one of the products that it breaks down into. Now, as we spoke about before, we'll set up a dynamic equilibrium. So we'll have the reactant breaking down into the product. We already have some product here. We'll form some of the other product, and this will keep happening until we reach equilibrium. So at equilibrium, at a temperature of 570 Kelvin, we have 1.44 moles of the reactant PCl5. The other thing that it tells us is we've got a 2 decimeter cubed container. Remember, this is going to be important later because at the moment we're talking about moles, not concentrations. So this is what we know. And what it wants to know is what Kc is. So looking at the method that we used before, let's set up one of these tables. So if we just, as a general rule, we start off with A, B and C amounts of each thing. Now at equilibrium, whatever is lost from A is going to be gained by B and C. We know this from the equation down here. 1 molecule of the reactant gives us 1 molecule of each product. Now what else do we know? We've been told that we're starting off with 1.68 moles of PCl5, and we are also putting in 0.36 moles of PCl3. So that's what we've got at the start. We've also been told that at equilibrium we have 1.44 moles of PCl5. Now what we also know is whatever is lost from here is gained on the other side. So whatever the difference is between this initial amount and the final amount here must have been in effect transferred to the other side. The amount of moles must kind of appear, as it were, on the other side. The other thing that we know is that we started off with no chlorine at all, no Cl2 at all, so our amount at the beginning here is 0. Okay, so what do we know? We know that we started off with 1.68 moles of PCl5. We know that we've lost a certain amount X, and we know that we end up with 1.44 moles. So we therefore know that this amount X must be 0.24 moles. That's the difference between the two. That's what we've lost to get our equilibrium amount. Now we also know that we started off with no Cl2 at all. So this 0.24 has been gained from an initial starting point of nothing. So therefore we've ended up with 0.24 moles of Cl2. On the other hand, we know that we started off with 0.36 moles of PCl3. So if the 0.36 moles had gained another 0.24 moles, because that's what we've said here, then we know that we must end up with an equilibrium amount of 0.6 moles. So we can put this in as well. So we now know our amount in moles of each of our products and reactant at equilibrium. These are our amounts, and remember this is an amount in moles. But remember, to get Kc, what we need is a concentration. Now we know the expression for Kc, we know that it's the concentration of the products over the reactants, but we need to work out what the concentration is. Now concentration is the amount in moles over the volume, and luckily our volume is in decimeter cubed. So all we have to do is divide each of our amounts in moles by the volume, and this will give us our concentration. So therefore our expression for Kc becomes 0.3 times 0.12 divided by 0.72. So we end up with a Kc of 0.050. But of course we need to know what the units are. Well, the units, we've got 2 lots of moles per decimeter cubed on the top of our equation and 1 lot on the bottom. These two cancel out. So overall 0.050 moles per decimeter cubed.